This is a case named Speeding Souza. Suspect Mr. Douglas Souza. His crimes consist of being bald, being a loser, and speeding. I'm Akeem Casella and Nathan Duman. The objective here was to prove Mr. Souza was in fact speeding, so Mr. Truckman can sue him for everything he has. We will do this by breaking the incident into three separate problems: a projectile motion problem, a big fish little fish problem, and a conservation of energy problem. First thing we had to do was make a scale model of the incident, and we had to determine a scale factor. We did this by taking the length of Souza's car and dividing it by the length of the scale car. This gave us a scale factor of 43.13 centimeters. And here are some of the actual dimensions of the crime scene. Actual length of skid marks, 7.7 meters. Height of cliff, 32.5 meters. Actual range, 13.3 meters. And the real length of Mr. Truckman's car is 4.96 meters. So Mr. Truckman's car is parked at the top of this cliff. Mr. Souza, not paying attention, hits it and knocks it off into a pile of turkey dung. The first thing we need to do is determine it's a projectile motion problem, and need to list the things we know in the horizontal and the vertical. In the vertical, we know the acceleration due to gravity is negative 9.8 meters per second. The initial velocity is 0 meters per second, and the displacement is negative 32.6 meters, or the height of the cliff. We're not sure of the time. So in the horizontal, we know the range is 13.4 meters. We don't know the initial velocity, that's what we're looking for, and we still don't know the time. We can figure out the time, though, by going back to the vertical and using the kinematic y minus y naught equals v naught plus 1/2 at squared. Solve that for t, plug in your numbers, and our time is 2.6 seconds. We take the time, plug it into the horizontal, and we use the equation x equals vxt, solving for vx, plug in 13.4 and 2.6, and your number is 5.2 meters per second. That is the velocity of the two cars going off the cliff. That's going to be our final velocity in the next problem. Our next problem is a big fish, little fish, or conservation of momentum. We just need to remember our final velocity is 5.2 meters per second, and we can say pi equals pf, mava plus mbvb equals mab prime. We can cross out mbvb because we know that is 0. The velocity of Mr. Truckman's car is 0. It's parked at the edge of the cliff. And mava equals mab prime. Solve for va and plug in your numbers. You get 9 meters per second. Now we move on to our next problem. It is a conservation of energy problem when he slams on the brakes and skids into Mr. Truckman's car. We can say EI equals EF, and the initial energy is kinetic, so 1/2 mv squared, and the final is also kinetic, but a little of thermal, so 1/2 mv squared plus fkd. Solve for VI, and just remember we have the 9 meters per second from the last problem. Plug in our numbers, and VI is 13.7 meters per second. Convert that to miles an hour. That is 30 miles an hour, and Mr. Souza is in fact going to jail, and Mr. Truckman can now sue him for everything he has. And that's a wrap.